Here are a few questions regarding estimating the population mean. First question, you have to find the critical value that corresponds to 91% confidence level. So first, the alpha level will be 1 minus 0.91, which is 0.09. And you punch into the calculator the inverse norm of 1 minus 0.09 over 2. So let's do that. Clear. Okay, so second vars, you go to inverse norm and put 1 minus 0.09 divided by 2, and then you just enter, and that gives you 1.6953, which if you round to the nearest hundreds, that's 1.70. So A is the correct answer for this one. Okay, second question. Determine whether the given conditions justify using the margin of error when finding a confidence interval estimate of the population mean mu. Well, using z means that you're using the normal distribution, so the question is whether you're allowed to use the normal distribution or not. And the condition is that if the number of sample size is bigger than 30, then you can. If it's less than 30, then depending on whether you have the standard deviation of the entire population and also whether the entire population is normal or not, it also matters. So if the standard deviation of the entire population is known, you can still use the normal distribution, but if not, you have to use the t-distribution when your sample size is less than 30, right? Here it's bigger than 30, so we just go by yes, regardless of whether you have the sigma or not. Okay, next question. Use the confidence level and sample data to find the margin of error E. Round your answer to the same number of decimal places as the sample mean unless otherwise noted. Okay, so you have this 99% confidence level, n equals to 76, and your sample mean comes out as 3016. And sigma is the population standard deviation. So that's usually not known, so that's kind of surprising, but that's given to us. So anyways, because sigma is known, then we just use the normal distribution. So let's figure out what the critical number for 99% confidence is. So for this one, you get 1 minus 0.99, which is 0.01. That's your alpha value. So your z alpha over 2 would be calculated using the inverse norm of 1 minus 0.01 over 2, and that's 2.576. Okay, 2.576. So that's the z alpha over 2. And then you use the formula, this is the formula for the margin of error, right? So it's 2.576 times sigma, which is 872, divided by the population size, which is 76. And you just calculate this. That's the margin of error. If the confidence interval was asked, then you should add or subtract this value to the sample mean. That's going to give you the bounds for the confidence interval. But let's just calculate this. So I want 2.576 times 872 divided by square root of 76, enter, 257, or close to 258. So the answer would be B. Use the confidence level and sample data to find the confidence interval. So we're looking for a confidence interval this time, so you have to add and subtract to the mean. But we first have to find the margin of error, and to do that we have to do the same thing again. So 90% confidence means alpha is 1 minus 0.9, which is 0.1. So z alpha over 2 would be use the calculator again, second vars, go to inverse norm, 1 minus 0.10, okay, and then enter, and you get 1.645, okay, so that's 1.645, and E would be 1.645 times the standard deviation 40 divided by square root of 105 is the sample size, right? So let's calculate that. So we're going to do 1.645 times 40 divided by the square root of 105, and then enter. You get 6.42. Okay, so that means you need to say the two values will be 441 minus, what was it, 6.42, or I guess they rounded to the nearest integer, so it would be 6. So 6.4 rounds to integer 6, right? So that's the interval, 441 plus 6. 441 plus 6 is 447, so this is the only one that matches, so this must be the answer.